Welcome to Common Fractions.
We're your crack team of primary school teachers and we're going to show you what it's all about. You ready, fellas?
Within this session, students are looking at common fractions, focusing on a subtopic of equivalent fractions. Equivalent fractions are different fractions that represent the same number. For example, 1/4 or 1/4 would be equivalent to 2/8. At this stage, students are progressing through level 1 and level 2 of the Australian curriculum. At this stage, the key skills we're acquiring are numeration and fractions. The primary aim is for students to understand that fractions need to be equal parts of one whole. This is learnt through the use of models. Pre-learnt skills expected at this level include counting and sequencing from numbers 0 to 20, supertising collections of objects, representing practical situations to model addition and sharing, and comparing collections of up to 20 things. At this stage, we find ourselves starting out by asking students exactly what half means to them. We may have examples such as half past the hour on the clock. Or at this stage in life, the idea of sharing and halving something would equate to giving each other an equal part. If we represent that with these chess pieces, which are handily in 2 different colours, we have 32 pieces here. So if you and I were to share these pieces, we would split them exactly in half, thus giving 2 equal sections. In turning to a paper-based model for this idea, the key skill we want children to understand in terms of numeracy is that 2 halves of one whole need to be equal parts. So in this instance, with this model, the important factor is to make sure that we form 2 equal halves. We've done so here. You may be able to, for example, colour code 1/2 of the piece in order that we now have green and white, so it's 2 separate halves of the whole, but importantly those 2 halves are of an equal size. Okay, in augmenting the paper-based model where we've essentially created those 2 halves, we can move into modelling with the pieces. Again, we've got the chess pieces. In this instance we have 8 pieces. Handily there are 4 of each colour, so it's easy for students at this stage to realise that we can just colour code them essentially to make those halves. If there's any difficulty with the concept, it's very easy to split them into those 2 equal parts, understanding that we have 4 and 4, which equates to 2 equal halves. Okay, and expanding on the use of models here, we've got different groups of chess pieces, obviously in different numbers. So kids now have to approach these and divide these different groups into halves, so they're not looking at just a set idea. And I've, in this instance, mixed up the colours so that we're not reliant on colour anymore. Obviously the initial easy one would be to separate the 2 halves. In this instance we have 3 and 3 making 2/3. Here we may need to count, so we have, you may find that kids perhaps split like this, but it's still setting out the concept of a half. So in this we have 5 and 5 split in half. We have a total of 10. Here we have lots of pieces, so we may use a variant on your skip counting if you like, where we're taking pieces 2 by 2. And we know there's 2 left at the end, so we split them in half, and 2 lots of 7. Okay, a final example using a paper-based model. We'd only really come to this, I think, when students have established that the 2 halves have to be equal parts to make a whole, because in this instance we've split 4 wholes into their halves and mixed the halves together. So kids will need to understand that we've got different sizes, but if we put those that are equal size together, they make the whole pieces. So it's just a further exercise to reinforce the fact that the 2 halves must be the same size.
Hi, my name is Tuan Fan, a Year 4 teacher at Cambridge Primary School, and this is my lesson on fractions. The main learning objective of this lesson is to get kids to understand fractions are a part of a whole and that different fractions are equal to each other. The lesson assumes prior understanding of common fractions such as 1/2 and 1/4. Also the initial concept of part-whole thinking, and basic fraction names and symbols. In the beginning part of the lesson, I get the students to write down all the things they already know about fractions. This will allow me to see any misconceptions and build on them throughout the lesson. So what kind of words did we come up with?
We came up with, what we did was we had 1/2 and then 1/2, and we got down to, I think, 1/4.
Great, Mike. That's all examples of fractions. In the lesson, I get the students to work together and give them the opportunity to share ideas. Often sharing those ideas, they come up with problems they wouldn't have working independently and be able to learn from each other. Now, has anyone got any ideas where you might come across quarters?
In the footy, it's in quarters, isn't it? All the games?
Very good. In the second part of the lesson, I asked the students to make their own fraction law. I feel by making the laws themselves, it assists a better understanding of fractions. They're making their own halves, quarters and fifths, and they can see that these fractions are equivalent to a whole. I'll begin with showing the students a completed fraction law and ask them to make their own by folding strips of paper that are provided equally. Each strip has the length of 1 unit. They should mark the fold lines and then write the length of the fraction piece on the paper as they create it. The fraction law activity I used allows students to explore fraction renaming using paper folding and rectangular regions. The series of rectangular regions displayed in descending order acts as a visual reminder that each rectangle represents one whole partitioned into equal parts. The activity engages the kids and allows them to get a deep understanding of fractions, but also recognise and appreciate equivalent fractions.
On Oswald 7, we learn about multiplication, and as 5 and 6 already have multiplication of simple fractions, we now move on to the multiplication of mixed fractions, whole numbers, and oversized fractions. So the equation we have for today is 1 and 3/8 times the whole number of 8. The simplest way to map out this equation I found is to use visual aids. And because obviously we're still children, I found the easiest way is to use food, because we all love food. So if you can imagine, if you will, that this is a tasty cake. We're going to split this cake into 8 even pieces. I am no artist. So we have one whole represented using 8 eighths, but we still need the remaining 3 eighths. So I'm just going to draw those on the side. There we go. So I'm now going to convert my mixed fraction of 1 and 3/8 into an improper fraction. So you need to add the 1, which is 8, and the top numerator, which is 3, and we end up with 11/8 as our improper fraction. So we now need to take our numerator of 11 and times it by 8. And because we are on Oz level 7, we can all work out that the final answer is 88, which now means we have an improper fraction of 88/8. So now we need to simplify our final improper fraction. So all we need to do is divide 88 by 8, and we all know our final answer is 11. Voila. Okay, so as we all know, when you come into year 7, you've forgotten pretty much everything you've tried to learn between levels 1 and 6. So coming back into fractions can be a difficult thing, especially when you're doing something as hard as multiplication, because we all know that even we can't do multiplication of fractions. So here is just a simple rhyme to help you learn the basics of multiplying fractions. Multiplying fractions, no big problem. Top times top over bottom times bottom. Don't forget to simplify before it's time to say goodbye. Yes!